Redistribution using route maps. Okay, how many of you recognize this scene? Ghostbusters! 30 years ago. This movie's a classic now, right? Where four guys investigating paranormal activity unleash this massive Stay Puft Marshmallow Man on New York City who kind of goes, Marshmallow! He goes around, kind of causing havoc until they blow him up with their ectoplasmic rays. Anyway, that's immediately what came to mind when I thought about route maps. Of all the filtering methods we have for redistribution, route map by far has the most mammoth impact on what we're able to do. As a matter of fact, when we get into BGP, route maps are going to be just a staple. You essentially can't function in BGP well without understanding route maps. So because this one is so massive and because it has such big impact, before we go straight into the objective, which is filtering 3 subnets in each direction, let me describe what route maps are. Route maps are the closest you will come to a programming language in your Cisco devices. I was recently talking to a friend of mine who codes in PHP, and he's like, dude, anybody can get programming. You just got to know if-then statements. If this, then that. If this, then that. Well, it's a really simple view. It's kind of true. Here's how this rules. So essentially, your Cisco routers normally route using, what, a routing table, right? So let's just say we've got network Y up here, network X over here. If I've got a host over here, a server, maybe .200 on network X saying, hey, I need to get to network Y, this router says, okay, well, let me look. I've got my routing table, oh, right there. Network Y says, go out this interface, and it follows the rest of the way until it actually reaches that network, right? Well, when you introduce a route map into the picture, and I'm talking about one specific use of it, which is policy-based routing, this host might come in and hit the route map instead of the normal routing table. And the route map is really a series of if-then statements. So it says, okay, route map, and you give it a name. So we'll just call it CBT, right? Route map CBT sequence number 10. Match, and you get to say whatever you want to match. Let's just say it's an access list matching this .200 host. And then you get to say set, and for policy routing, most of the time you'll say something like the next hop or the exit interface, or there's a lot that you can actually set, but that's really all route maps are, is a big series of match set statements. So you would do sequence 20, match this, set this, sequence 30, match this, set this. Now, I'm using these sequence numbers kind of in increments of 10 because that's what a lot of people do. So you can come back later and squeeze entries in. It's like basic programming, or you can use these sequence numbers to reorder or insert steps in between your steps. But for policy routing, that's all it is. But you notice there's a few other things you can use it for. You can use it for modifying BGP attributes or route filtering. And that leads us back to this slide, redistribution with route maps. I figured I could show you the route map syntax and show you route filtering all at the same time. So we've got 3 different routers, ham, steak, and eggs, with 2 different routing protocols, RIP and OSPF. Now, I'm not doing redistribution as of yet, so we'll go to the steak router, which is this guy in the middle, and make some magic happen. So we'll hit steak, config T, router RIP. We'll do a redistribute OSPF. Do process ID 1, metric, you got to set a metric when you're sending into RIP. We'll just do 5. So all the routes from OSPF into RIP are going to start using a hop count of 5. That's their seed metric, right? We'll then go into router OSPF 1, and we'll do redistribute RIP, and we'll do a metric of, let's do 5 there as well, and we'll do subnets to make sure all the individual subnets come across. So coming over here, all these routes will also start with a cost of 5 instead of 5 hops in the OSPF world. Let's just verify. I'll hop over to the ham router, which is our RIP router over on the left-hand side, and we should see, let me just bring that to the front, we should see now show IP route or row. I should see all the OSPF routes making their way over, now looking like RIP routes. That's good. So steak stands in the middle that has the ability to do route filtering. How do we do it? Well, route maps usually rely on other mechanisms to match things. Meaning, I just said that route maps are really a series of if-then, which I called match/set statements. But in order to match things, they typically will rely, for instance, on an access list. Or they might rely on quality of service tags. Or they might rely on some other flag or matching mechanism that we have. In this case, I'm going to use an access list. So let's just do access list. I'll just use 5. We'll permit, we'll use this to filter RIP routes going into OSPF. So I'll permit 10.1.1.0, 000.255. Now as I'm typing this, some of you might be like, well, wait a sec. Jimmy, Can't we use a distribute list, which is another route filtering mechanism with an access list? Well, absolutely you can. However, a route map gives you more flexibility. I'll show that to you in just a second. Let's while we're here, let's just create an access list. We'll do 6 for going the other way. I'm going to permit 172.17.10.000.255, and then hit the up arrow and create that. So essentially, I have an access list that I can use to filter OSPF routes into RIP, which is what I just created right here with these 3 guys, and then RIP routes going into OSPF that permits these 3, which remember, we're after filtering 3 subnets in each direction, so I'm going to allow these 3 and then deny the rest of them on both sides, right? Now the magic, the route map. To create the route map, I'm going to type in route-map, and you give it a name. You can name it whatever you want. It is case sensitive. I'll just name it Jeremy. Then we type in what sequence numbers, and we use permit or deny and all that. Now notice, one of your options is just to hit enter here. If you do, the Cisco router is going to create sequence number 10, just like I was showing you on the previous slide, saying this will be the first line, essentially sequence 10 of the route map. Now, by making it sequence number 10, that means you can squeeze lines above it by typing in route map Jeremy, and you can just type in sequence 9, sequence 8. You can squeeze things in there. Also notice that we have a permit or deny. I do not like using deny in a route map just because it can get confusing. Sometimes it's necessary, but trust me, once you get into route maps, it's like, deny statements hurt my head. Almost always I'm going to use permit, which is what's implied if you just type in a sequence number, right? So if I type in route map Jeremy 10, it's going to assume permit 10, right? Same thing. So now I'm under the route map. I'm into my first statement of the route map. Notice when I hit the question mark, there's not much to them other than match and set. So if I type in match, this is what do I want to match under this route map? Most of the things here deal with BGP. This is a big BGP, like it's almost impossible to do anything worth value in BGP without using a route map. But in this case, I'm going to say I want to match IP information. So I'll say IP space, and now notice next hop, a certain source, or address. I want to match an address of, and then it gives me the option to say, well, what access list are you matching? And so I've got this route map Jeremy where I'm going to say, well, I'm going to match access list number 5 right here, right? Where I've matched the routes that I want to allow to come through. So I'll type in on here 5, right? And hit enter. Notice we can also match named access lists. We can use route maps to match prefix lists, which is another route map mechanism. By the way, it's virtually impossible to even use prefix lists if you don't use route maps, because route maps are your mechanism. It's like the mechanism that empowers prefix lists to work. You can't prefix lists, you can just create them all day, but can't really apply them without a route map. Okay, so I've got, let's just get our bearings. I've got a route map now. I'm going to do a show route-map, and I've got this route map called Jeremy. It's got sequence number 10, and in there it's saying I'm going to match this, which says match access list 5, and I'm going to set nothing. Now, I could, if I wanted to in this demo, I could do route map Jeremy and go back under that sequence number 10, and I could say, no, actually I want to set, and you can see I have a whole bunch of things. Again, BGP. Notice how much BGP you see in here. I could set something, but most of the time it doesn't apply. Like I'm not doing anything with BGP traffic index or origin codes or NLRI types or anything like that. Now, here's something. I could match the metric, or I should say I could set the metric if maybe I wanted to overrule the default. Sure, let's do it. Let's just say I want to set the metric to be 1,000, right? Enter. So I just go in there. Now let's go back and do a show route map. See what I've got. Route map Jeremy, sequence 10, which matches access list 5, and it says, by the way, when I get this, I'm going to set the metric of 1,000, right? Everybody following so far? So this is, again, notice that it's like if, so again, if, then. Now I could put in there, I could say, okay, and I'll do route map Jeremy, sequence, or hang on, let me type there, route map Jeremy, and I could do sequence 20, and I could type in and just keep adding lines that are like access list statements to that route map. But for now, I'm just going to keep it at this, and I'll explain why in just a moment. I'm going to go now into router OSPF 1, and I'm going to do, well, first off, let's come back here. I'm going to go to the, let me just clear this off. We've got the ham router. Okay, I'm on the eggs router. So this is the router on the right-hand side of the console, which is the OSPF router that's going to receive those routes. I'll do a show IP route, hit enter, and notice I've got a whole bunch of routes. Okay, there's our OSPF routes. Stake is redistributing them, so they're coming in as external type 2 routes. Notice the metric. They're all tagged with a cost of 5. Everybody following so far? Good? Good. So eggs, getting those from stake. Rip routes coming through. Okay. Now, let's go to stake. I'm so hungry right now. All right, so I'm at the stake router. I'm going to do a redistribute rip, and this time, notice right smack in the middle of my options is route map, and I'm going to say Jeremy is going to be the route map that I'm going to apply, and then I can continue down the list. I'll do my subnets and whatever else that's in there. Now I've done a couple redistribution commands. I just want to make sure it took. I'll do a show run section router OSPF. Just verify. Yep. Okay, so I've got, look at this. I've got a metric of 5, and I'm saying redistribute the subnets in a route map Jeremy where I set the metric to 10, right? Let's see what happens here. I'm going to come back here to the eggs router. Let's bring it to the front. Hit the up arrow, show IP route. Or wait, no, I set the metric to 1,000. Look at that. Look at that. Look at that. Isn't that so great? So what happened? It got small. Initially, I can see that I had all of these routes coming through as external type 2. Now what do I have? 3 of them. Which 3? The 3 that I permitted using that access list. Everything else was filtered because that route map, let me go back, I'll do a show route map Jeremy. That route map just said permit this, match this, essentially these, and set everything else to 1,000. Now, oh, you ready for this? Hang on. Oh man, we could go so far with route maps. I'm so excited, but hang on. There was a reason. Remember, I was right here. I said I could also go in here and do a route map, Jeremy, permit 20, right? But notice I didn't hit the enter key. You know why? As soon as I did that, I added another line to my route map. Look at this. Show route map, Jeremy. I've got permit this, and then it says match this and do this, right? Everybody follow that so far? Now notice I've got sequence 20 matching nothing and setting nothing. Now you might say, well, okay, what's the point? Is there something special I'm supposed to know? Well, yes, actually there is something very special. This blank sequence number is like a permit all. Watch this. Do I show IP route? Notice what just magically reappeared. Oh, and this is so good. Look at this. And look at what the metric is. The routes suddenly made their way back in. I don't know why the State Puff Marshmallow is coming to my mind right now. State Puff, whoa, they're all sneaking back in now because this permit statement on here with nothing under it is like a permit any. Matter of fact, watch this. I'm going to go into, why do I feel like a magician right now? I'm going to pull a rabbit out of my hat. Just hang on one second. Set the metric to, let's go 500, right? So now I've got a route map Jeremy, which says, for these guys, set the metric to 1,000. For everything else, because I don't have a match statement, which is a match everything, set the metric to 500. What do you think is going to happen? Boom! We've got 500 showing up on all these other routes. Isn't this awesome? Can't do that with a prefix list. At least not alone, not until you combine it with a route map. This is why route maps are so powerful, is they give you the ability to do all kinds of match and set and applications. I'm just setting the metric right now. I mean, why not? Let's go one more step. Come on. I'm going to go in there and I'll do a I'll do a set. What am I going to do? I'll do set metric type type 1. Remember, with OSPF, you have 2 types of external routes. E2, which increments the metric as you go. Or no, sorry. E2 does not increment the metric. E1 routes will increment the metric as you go. If you don't know what I'm talking about, check out OSPF redistribution in all its glory. That's anyway. I'm going to hit the up arrow. Do a show IP route. Check them out. E1, E1, E2, because now we have multiple set statements under there. So my goal here is not to show you everything you can do with a route map, because there's a ton of stuff. My goal here is to open your eyes so that you're able to see the syntax of route maps. You're able to see how they can be applied in all, well, I won't say all, but some of the power that we have with those route maps. Oh man, I've got all these command prompts. They're like the State Puff Marshmallow Man of route filtering and of route capabilities, where you can apply all kinds of different settings using them. Well, you now know the general syntax. You've seen how to filter using route maps. You've learned a lot. I hope this has been informative for you, and I'd like to thank you for viewing.